Welcome to Module 5 of our CCNA journey, where we start building one of the most important routing protocols you'll encounter in the field. Over the next few lessons, we'll unpack OSPF, Open Shortest Path First, the industry standard link state protocol that runs in networks of every size. Think of this first lesson as setting the foundation, what OSPF is, why it exists, and how it thinks about the network around it. So, what actually makes OSPF special? At its core, it's a link state protocol, meaning every router builds a complete map of the network, called the LSDB, and then runs the Dijkstra algorithm to compute the shortest path on its own. It's an open standard, so it works across any vendor, it converges quickly, and its cost metric is based on interface bandwidth. The flow is straightforward. Meet your neighbors, exchange link state advertisements, build the map, run SPF, and install the best routes into the routing table. So let's start at the beginning of that flow, meeting the neighbors. Before any routes get exchanged, two OSPF routers have to agree on a handful of values inside their hello packets. They need to be in the same area, share a subnet, and run matching hello and dead timers. If authentication is configured, that has to line up too, and the MTU on both interfaces must match. Miss any one of these and the neighbors get stuck. No LSDB, no routes, nothing. Once neighbors are up and the database is syncing, you start to hit a scaling problem. In a large network, every router holding a full topology map gets expensive. That's where areas come in. They split the OSPF domain into smaller chunks, each with its own LSDB, so changes in one area don't ripple through the whole network. Area 0 is the backbone, and every other area has to touch it, usually through an area border router. For the CCNA, you'll mostly work in the single area OSPF, but it's worth knowing why multi-area exists. So let's actually configure it. You enter OSPF with router OSPF1 SARS. That number is just a local process ID. It doesn't have to match between routers. Then set a router ID for stability and use the network command to tell OSPF which interfaces to run on, each with a wildcard mask and an area number. Remember, the wildcard is the inverse of the subnet mask, so 0.00.255 covers a 24. And 0.00.0.3 covers a 30 point-to-point link. Once that's in, show IP OSPF neighbor confirms your adjacencies are forming. And that's where we'll stop for this lesson. In the next one, we'll go deeper into OSPF neighbors, the states two routers move through as they form an adjacency, and how a DR and BDR get elected on multi-access networks like Ethernet. If this lesson helped, hit subscribe and turn on notifications so the next part lands in your feed. The full course lives on Dargslan.com whenever you're ready to keep building. See you in Lesson 2.